Adding fractions with different denominators. If the largest denominator in a problem cannot be evenly divided by all the fractions, then a new number must be found that can become a common denominator. For example, 3/5 plus 3/4, we know since the denominators are different, we're going to have to get a common denominator. We can make this problem a little bit faster by checking with the largest denominator, which in this case happens to be 5. We want to check all the multiples of 5 and see if they're divisible by 4. You find the multiples of 5 simply by using the multiplication table. If I use 5 times 1, I get 5. And I know 4 doesn't go into 5 evenly. If I use 5 times 2, I get 10. 4 doesn't go into 10 evenly either, so I need to keep going. 5 times 3 is 15. That doesn't help me out. 4 won't go into 15. 5 times 4 is 20. I think I've hit the jackpot with 20 because I know 4 will divide evenly into 20. So my least common denominator is going to be 20 for this problem. Now I'm going to write my problem vertically. So I have 3/5 plus 3/4. I know that I want to have a common denominator of 20. So I'm going to be changing these fractions into equivalent fractions that have the denominator of 20. Each of these fractions, when I'm done, will be in terms of 20ths. I want to change this fraction into a fraction with 20 in the denominator, and I know I need to do that by multiplying the denominator of the fraction by 4, since 5 times 4 will give me 20. But I also know that whatever I do to the bottom of a fraction, I need to do to the top of the fraction as well. So I'll multiply the top by 4. 5 times 4 gives me the desired 20. 3 times 4 is 12. In the next fraction, I want to change the 4 into a 20. So I know that I need to multiply that by 5. Whatever I do to the bottom of the fraction, I need to do to the top of the fraction. 4 times 5 gives me the desired 20. 3 times 5 gives me 15. So I've changed my problem from 3/5 plus 3/4 to an equivalent problem with similar denominators, 12/20 plus 15/20, and I'm ready to add. When I add 12/20 and 15/20, I know that the denominator won't change. I only need to add the numerators. So I have 27/20. Of course, I recognize that this is an improper fraction, and I'll want to change it right away to the mixed number 1 and 7/20. So I started with the problem 3/5 plus 3/4. I found the least common denominator by looking at the multiples of the largest denominator. I changed my problem to equivalent fractions with a common denominator of 20. I added them and I got the answer 1 and 7/20. So 3/5 plus 3/4 is 1 and 7/20. Our second example is the one that we have on the board. We want to add 4 and 5/6, 2 and 1/2, and 5 and 3/4. Adding a problem with 3 factors in it is no more difficult than adding one with 2. We just want to make sure we get a common denominator. Once again, we're going to look for the largest denominator, which is 6. And we want to find all the multiples of 6. We're looking for that magic multiple that's divisible by 2 and by 4. My first example is 6 times 1. Well, I know that 6 will go into it. I know that 2 will go into it, but unfortunately 4 will not. The second thing I'll try is 6 times 2. My second multiple of 6 is 12. 6 goes into 12 evenly, 2 goes into 12 evenly, and 4 goes into 12 evenly. So I know I have found my lowest common denominator. And I'm ready to begin to add the problem. I'm going to write these numbers vertically. 4 and 5/6, 2 and 1/2, and 5 and 3/4. And I'm going to get ready to add them all. I'm ready to add the whole numbers, but I need to change these fractions to fractions that have a common denominator. And I want that denominator to be 12. So this problem becomes 4 and something over 12. This problem will become 2 and something over 12. This problem will become 5 and something over 12. I want to have that common denominator. Now when I'm changing these fractions into their equivalent form, I need to figure out what I need to multiply by to get the denominator to equal 12. I've got a 6 here, and I know that 6 times 2 will give me 12. If I do it to the bottom of the fraction, I need to multiply the top of the fraction by 2 as well. 5 times 2 is 10, and 6 times 2 is 12. So 4 and 5/6 is equivalent to 4 and 10/12. In the next example, I'm trying to change 1/2 into 12ths. I need to multiply 2 by a number that will make it equal 12. So I'll multiply it by 6. If I multiply the denominator by 6, I have to multiply the numerator by 6 as well. 1 times 6 is 6, and 2 times 6 is 12. So 2 1/2 is equivalent to 2 and 6/12. Finally, if I want to change 3/4 into a fraction that has 12ths as a denominator, I know I need to multiply by 3. Since I've multiplied the denominator by 3, I want to be sure to multiply the numerator by 3. 3 times 3 is 9, and 4 times 3 is 12. Now I've changed all of these mixed numbers to equivalent numbers that have a common denominator. I'm ready to add them together. When I add the fractions together, I know the denominator will continue to be 12, and I'll add the numerators together. 10 plus 6 is 16, plus 9 is 25. And then I'll add the whole numbers together. 4 plus 2 is 6, plus 5 is 11. And I've come up with an intermediate answer of 11 and 25/12. I know that I have an improper fraction, so I need to change it to a mixed number. This problem is equivalent to 11 plus the mixed number form of 25/12, which is 2 and 1/12. When I add those together, I get 13 and 1/12. When I come back to my original problem, I wanted to add 4 and 5/6 plus 2 1/2 plus 5 3/4 for a final answer of 13 and 1/12. For my third example, I've chosen to add these three numbers together. We'll add 3 1/2, 4 7/10, and 6 1/3. These have very different denominators, so we know the very first thing that we're going to want to do is find the least common denominator. 10 is the biggest number, so after a little bit of investigation, we can find that 30 will be the least common denominator for these numbers. 2 goes into 30 evenly, 10 goes into 30 evenly, and 3 goes into 30 evenly. So what I'm going to want to do is change each of these mixed numbers to mixed numbers that have denominators that are the same. This problem will become 3 and something over 30. The second problem will become 4 and something over 30. And the final problem will become 6 and something over 30. When I'm changing this to 30ths, I want to find out what it takes to change a 2 into a 30. I know that I need to multiply it by 15. And if I do so on the bottom, I should do so on the top as well. That would give me a fraction of 3 and 15/30ths when I multiply these numbers together. In the next fraction, I want to change 10 into 30ths, so I need to multiply by 3 on the bottom. That means I need to multiply by 3 in the numerator as well, giving me an equivalent fraction of 4 and 21/30ths. And finally, if I want to change 3 into 30ths, I need to do so by multiplying it by 10. So I'll multiply 10 in the numerator and the denominator, and that will give me an equivalent fraction of 6 and 10/30ths. Now that I have my mixed numbers that are equivalent to the original numbers, but also have a common denominator, I'm ready to add them together. I'm going to add the fractional part of these numbers first. I know that the common denominator will be 30 and it will stay unchanged. When I add the numerators, I have 15 plus 21, which is 36, and 36 plus 10, which is 46. On the whole numbers, 3 plus 4 is 7, and 7 plus 6 is 13. So my answer, at least in the meantime, is 13 and 46/30ths. I recognize right away that this is an improper fraction, so I'm going to change this to 13 plus 1 and 16/30ths. When I add these two numbers together, I get the mixed number 14 and 16/30ths. But as every math student should know by now, we don't want to leave a fraction in its not reduced terms. This fraction is reducible. I can divide both the numerator and the denominator by 2. When I do that, I'll get 14 and 8/15ths. 16 divided by 2 is 8, 30 divided by 2 is 15. So back to the original problem. I wanted to add 3½ plus 4 7/10 plus 6 1/3. I changed them to equivalent numbers with common denominators, added them together, changed my improper fraction to a mixed number, and finally reduced my remaining fraction. These numbers added together have a value of 14 8/15.
You're a draftsman, and you're going to design a building, and you're putting together these two boards. One is a 2x4, and one is a 1x8. And you want to design the building with these two boards put together. Now, first of all, when you purchase lumber, a 2x4, and I got this off of the internet, and it gives you the list. A 2x4 is actually 1½ by 3½. 1½ inches by 3½ inches. And this, called 1x8, actually measures 3/4 by 7 1/4. So even though they call it the size, like a 2x2 is 1½ by 1½, and a 1x6 is 3/4 by 5½, and you will find that these sizes are not the actual sizes. But the question is, you're a draftsman, and you're designing this building, and you want to put these two boards together, the 2x4 and the 1x8. So one board measures 1½ inch, and the other board, this one measures 3/4. So you want to find out what is the dimension between these two boards. So we have to add them. So 1 1/2 plus 3/4 equals. So we got to have the common denominator, and that's 4. 2 goes into 4 2 times, times 2, times 2, 2/4. That will be 3/4. We have to add them. That's 5/4 plus the 1. We want to reduce this to the lowest terms, and that will equal 1 1/4 plus the 1, and that will equal 2 1/4. So 1 1/2 plus 3/4 equals 2 1/4. Let's look at another problem. A recipe calls for 1 1/2 cups of white sugar and 2 2/3 cups of brown sugar. How much is the total amount of sugar in the recipe? So you have to add 1 1/2 plus 2 2/3. Now we want to get the least common denominator for both these fractions so we can add them together. And so the least common would be 3, 6, 2 goes into 6, so 6 would be the least common denominator where both numbers could be divided into. 3 goes into 6 2 times, so it's 3 times 2 times 2 equals 4/6, so 2/3 equals 4/6. And 1/2, 2 goes into 6, goes 3 times 3 is 3/6. And remember, 1/2 is the same as 3/6. Likewise, 2/3 is the same as 4/6. Now we can add these fractions together. That would be 7/6. 2 plus 1 is 3. We have to reduce this to the lowest terms, equals 6 goes into 7, 1 1/6. 3 plus 1 1/6 equals 4 1/6 cups of sugar. So this recipe has 4 1/6 cups of sugar. Finish these 2 pages and then take the test. Don't forget, double check your answers. And also remember, there's additional helps and additional tests right after this test and also in the back of the book. Use them to help you master fractions.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.